All right, so this is lesson 7.2, similar polygons. You will learn to identify and apply similar polygons. So let's do a little review here. What does it mean when two segments are congruent? It means they have the same measure. What does it mean when two angles are congruent? That also means they have the same measure. And it says measure each segment, then circle the congruent segments. I'm not going to do that, but I would guess that maybe these two are congruent if we measure them. All right. How are two squares at right similar? They are similar because they have four angles that are the same measure. Are they not similar? And I would guess you would say their sides are different. But really all squares are similar. All right, so here's what we're going to use, similar polygons. This is like the definition of similar here. Two polygons are similar if corresponding angles are congruent and the lengths of corresponding sides are proportional. So if we say that ABCD is similar to GHIJ, and notice that symbol, that's how you mark two things being similar. Okay, so draw a line from each angle to its corresponding angle in column B. If we do that, we get A goes with G, B goes with H, C goes with I, and G goes with J. And if we complete the proportion, AB is to GH as BC is to HI, as CD is to IJ, and AD is to GJ. Okay? So, problem one here. Triangle QRS is similar to triangle DEF. What are the pairs of congruent angles? Well, when you mark two things being similar, you also line up the parts that are congruent or corresponding ratios. Anyway, so we know that angle Q matches up with angle D, so we can say angle Q is congruent to angle D. We can say that angle R is congruent to angle E. And angle S is congruent to angle F. All right, and the proportions we get from that are like this. QR, segment QR, the length of QR, that ratio to DE is equal to the ratio of, say, RS to EF, and the ratio of SQ to FD. All right, let me try that. Check back for the answers. All right. Determining similarity. Are the polygons similar? If they are, write a similarity statement, the scale factor. All right. If they're similar, that means that the corresponding angles are congruent, and that the ratios of corresponding sides are equal. So we're going to check that out by doing this. So as the angles are marked, we would, if they are congruent, or if they are similar, we would say ABC is similar to FED, just putting the appropriate angles together there. But first we have to make sure that the ratios of corresponding sides are equal. So we're going to take like side AB, which is 15, and compare that to side FE, which is 30. So we get 15 over 30. And then we're going to do side ED, make sure that BC over ED is the same ratio. So BC is 17 and ED is 34. And so far we have them equal. Those are both equal to 1/2. And then we'll check the last one, which is AC, that's 8, and FD is 16, so we have 8 over 16. And if we simplify all those ratios, we get 1/2. So we can say that triangle ABC is similar to triangle FED. All right? So on these two rectangles, doing the same thing, we can see that the corresponding angles are congruent because they're all 90 degrees, so we're good there. And as they're orientated, we would probably, what we're looking for is LM and O similar to QRST. So let's check the ratios of corresponding sides. ON corresponds to TS, so we're going to say that ratio is 4 over 6, which if we simplify that, we get 2/3. And then the other ratio we get is LN to RS or QT, since both sides are the same. So 10 over 16, if we simplify that, we get 5 over 8. And 2/3 is not equal to 5 over 8, so we're going to say that these are not similar. All right, you can try it. Check back with the answer. All right, using similar polygons, so WXYZ is similar to RSTZ. What is the value of X? Remember that the ratio of corresponding sides are equal. So corresponding sides ratio, of course, we should have a proportion there. So we can use a proportion to solve this. And what we can say is that X over 20, because those are corresponding sides, X over 20 should be the same as 16 over 24, another set of corresponding sides. And then I can solve that by using the cross products property. And that would tell me that 20 times 16, which is 320, is equal to 24 times X. And if I divide both sides by 24, I get 13.3 equals X. So I'm going to go with answer B here. So I try the next problem using proportions and similar polygons to solve the problem. Check back with your answer. All right, problem 4, using similarity. Jan uses an overhead projector to enlarge a picture 5 inches high and 7 inches wide. She projects the picture on a blackboard 4 feet 2 inches high and 12 feet wide. What are the dimensions of the largest picture that can be projected? Okay, when you project, you get a similar image, just grown, but grown in the same proportions for the length and the width. So here's our original picture. This is 5 inches and this is 7 inches. And then we have a new picture, or we have a blackboard that's, and I'm going to change these feet to inches. 12 feet wide is 144 inches. And then 4 feet 2 inches, that's the same as 15 inches. Okay, now if I enlarge this screen as big as I can, that means I can enlarge the height 50 divided by 5, which is 10, times. And I can enlarge the width 144 divided by 7, which is like about 20.6 times. And so, so the most I can enlarge this picture is 10 times, because any more than that, and my height would go beyond the size of the blackboard. So I'm going to use these numbers to come up with my new dimensions. So 5/50, that's this ratio. That's going to be the same as 7 is to the new length, which I'll use L for that. And so 5L is equal to 7 times 50, which is 350. Divide both by 5, and I get L equals 70. So my answer is, the dimensions are going to be 50 inches by 70 inches. So you try it. See if you can come up with the right answer here. All right, using a scale drawing. So in this problem, we are going to use the scale drawing. Now, if you measure this little post here on your paper, when I measured it, I got 0.8 centimeters. And we're going to let h equal the height of the tower. And then, since we have a scale of 1 to 200, we're going to use that as our ratio, 1 being the drawing scale, 200 being the actual size, and that's in meters. So I come up with this proportion, 1 over 200 is equal to 0.8 over h. And when I solve that, I do 200 times 0.8 is equal to 1 times h, and that's equal to 160. So the actual height of the towers is 160 meters. All right, and the lesson check. That's it. See you tomorrow.